Last week when we were solving quadratic functions, we factored or we solved by square roots, and we figured out that our solution was also our x-intercepts, or zeros we can call it also. So today we're going to do more of that to use the x-intercepts to help us graph, but then we're also learning a new form called vertex form. First, let's take a look at the warm-up. We have a quadratic function in standard form, and in order to find the x-intercepts, we would want to try and factor it. So that's where we have two numbers that multiply together to be 16 that add up to be -8. In this case, it's -4 and -4. Those are going to be placed over 1x. So our two factors are x minus 4 and x minus 4. So they're the exact same thing. If we set those equal to 0 and solve, add 4 to both sides, you get x equals 4. You would get the same thing for that second factor. So we actually have one x-intercept at 4, 0. So we don't have a second one. It's only at 1. Let's take a look at Desmos to see why something like that might happen. So look at the graph. If we put in y equals x squared minus 8x plus 16. And we could see right here, it hits the x-axis at 4, 0. It's also the x-intercept. So the vertex and the x-intercept are the same because it's bouncing off of the x-axis. And then we could also, while we're here, look at the y-intercept of 0, 16. That's our c value when it's in standard form. So when we go back to this, our vertex was also at 4, 0. The axis of symmetry is the line that goes through the vertex. So that's at x equals 4. And we had said the y-intercept is at 0, 16. So kind of taking a look at the other problem, next problem, it's a different form. That's not in standard form. That's not y equals ax squared plus bx plus c. So we're going to use Desmos to kind of help explore a little bit with some of the problems that we're doing. The graph for this one is actually provided for you. So if we look at the vertex, we know it's right here, and we can count that's at 2, -4. The axis of symmetry, we know, is that line that causes that mirror image on both sides. It goes right through the vertex. That's at x equals 2. The x-intercepts, we could see, hit here and here. So at 0, 0, and then at 4, 0. And then the max or min of the function, we know that this vertex is a minimum value, and it's down at -4, so it's a minimum of -4. It's always our y value. So we want to look, do any of these features play a role in the equation above? So looking at the new equation, this stuff right here, is there some connection to some of these numbers that we found? And if you look, I see this -4, and I see the -4. I wonder if there's a connection there. I see a -2 and a +2 here. So I'm wondering if there is some sort of connection to that, and there is. So the vertex does play a role. So what that form is actually called vertex form. And here's the breakdown of what it is. Y equals a times the quantity x minus h squared plus k. The axis of symmetry we know is a vertical line. It's x equals, and that goes right through the vertex, and that's this h value. That number right there is going to be the axis of symmetry. The vertex has the coordinate of hk. And then to find the x-intercepts, you substitute 0 in for y, right here, and then solve using square roots. So that's the stuff that we had done last week. So let's take a look at a couple of these. The vertex, the equation is x minus h squared. But what I have here is an x plus 3. So in our head, we kind of want to think about the opposite of what's in parentheses. Because in order to get x minus to make it a plus 3, it's an x minus a negative 3, if that makes any sense. So the vertex is negative 3, and then it's our k value of positive 1. So the vertex is opposite inside the parentheses for the x, and then it is the number that's on the outside, plus 1 in this case. Let's look at the next one. This one says it's x minus 9. And then I have my k here, which is a negative 2. Over here, y equals x minus 2 squared plus 5. So it's a minus what number? 2. And then I have my positive 5 right there. So it's the opposite of what's in parentheses. And then it's the normal number that's on the outside. What about this one? So this is a positive 4. So that's like x minus a negative 4. So my vertex is going to be at negative 4. But what's my k value? I don't have anything there. Nothing is being added. So then I have a 0. So negative 4, 0 would be that vertex. Sliding over here. X plus 1, opposite in parentheses, would be a negative 1. And then we have this number on the outside, negative 6. This one has no number in parentheses. If we're looking at x minus h squared plus k, there is no h. That's a 0. And then I have my k value of negative 7. So what I want you to do is take a look at these next couple, and I'm going to provide you with the answers. If you look at this first one, you end up getting the vertex to be at 1, negative 4, and the x-intercepts at negative 1, 0, and 3, 0. And just remember, to get the x-intercepts, you put 0 in for y, and you solve. So that's what we did last week. I want to go deeper with this problem. So the vertex, since it's an x minus h, I have just a 2 there, and then this value of negative 16. To find the x-intercepts, I put 0 in for y. I'm just going to rewrite that with it on the right side, but we know it's the same thing. So my first step would be to add the 16. So I'm getting a negative x minus 2 squared equals 16. And then I would either multiply or divide both sides by a negative 1, because there's a 1 out in front there. So then I'm left with x minus 2 squared equals a negative 16. So then from last week we learned you square root both sides and you get a plus or a minus. What I want you to see here is there's a negative 16 in there. We can't take the square root of a negative number. So that's no real solutions. which means there are no x-intercepts. But why? What does that mean? Let's take a look at the graph on Desmos. So it's y equals a negative x minus 2 squared and then minus 16. And we look at our graph, it doesn't even show up anywhere. Well, our vertex is here at 2, negative 16. We knew that. But if you look up here, it never crosses the x-axis because it was opening down with the negative out in front and the vertex was below the x-axis. So that's why we're going to get no solution for that one. So no x-intercepts. I want you to go ahead, take a look at the rest of these problems. I will post the answer key as well, post the homework for you to do and turn in, and then of course just message me with any questions. Have a good day.